All right, let's take a look at our practice test. We're told to solve each word problem. And let's start with our first problem. So we have that Melissa, a hardware store clerk, has $336 in $1 bills, $10 bills, and $20 bills only. Melissa has double the number of $1 bills as $20 bills. Additionally, if the number of $1 bills was decreased by 1, there would be 5 times as many $1 bills as $10 bills. How many $1 bills, $10 bills, and $20 bills does Melissa have? So the first thing is we're trying to find out how many $1 bills, $10 bills, and $20 bills Melissa is going to have in this register. So what I want to think about first is just letting a variable like x be equal to one of these, and then I'll model the other ones based on that. So let's let x be equal to, if you read back through the problem, you'll see that the number of $1 bills is involved in both comparisons. So generally speaking, it's easier to use that one. So I'm going to say we're going to let x be equal to the number of $1 bills. Okay, so how can we then model the number of $10 bills and the number of $20 bills? So coming back through here, if we just read, Melissa has double the number of $1 bills as $20 bills. So just reversing that, I can say, well, that means she has half the number of $20 bills as $1 bills. And since x represents the number of $1 bills, 1/2 x would represent the number of $20 bills. So I'm just going to put then. So I'll put then 1/2 x is equal to the number of, in this case, $20 bills. Okay, let me make this L here a little bit better. Coming back through, we now need the $10 bills. So what are we going to do for that? Let me change colors here. And I'll put then. Coming through, we see additionally, if the number of $1 bills was decreased by 1. So that would mean x minus 1 because the number of $1 bills is x. So we would go x minus 1 to represent that. Then it says there would be 5 times as many $1 bills as $10 bills. So this right here is 5 times as much as the number of $10 bills. So to get the number of $10 bills, I'd want 1/5 of this amount. So let's just slide this down and I'll put 1/5 times this. And this will be equal to the number of, in this case, $10 bills. So the main mistake that people make when they're solving these problems, they set x plus 1/2 x plus 1/5 times equality x minus 1 equal to this 336 that they get in the problem. But that doesn't work. And the reason it doesn't work, I want you to think about having, let's say, 6 $20 bills in your pocket. You don't say, hey, I have 6 $20 bills in my pocket, or you might say that, but really you think about the value, right? So you'd multiply 6, the number of $20 bills you have in your pocket, times 20, the value for each bill, to get $120. That's how much money you have in your pocket. So what we're going to do is make a little table here. I'm just going to come down. And what I'll do is I'll put, this is the $1 bill, this is the $10 bill, and let's say this is the $20 bill. And I'll just put the number, which we modeled earlier. So this one was x, and then this one was 1/2 times x, and this one was 1/5 times the quantity x minus 1. Okay, so for this column right here, what I'm going to do is put the value for each. So the value each I'll just put, maybe to abbreviate. And basically, for each one, you're just going to take this and not use the $sign. So I'm just going to say this is 1, this is 10, and this is 20. In other words, each $1 bill is worth $1. Each $10 bill is worth $10, and each $20 bill is worth $20. Then you want the total value. So you're just going to multiply across. So this is the total value. And I'm going to say 1 times x would just be x. And then 10 times this 1/5 times the quantity x minus 1. Well, 10 times a fifth would be 2. And you can distribute this now if you want. This would be 2x minus 2. Might as well just do it. So this is 2x minus 2. And then here, you would have 1/2 x times 20. So 1/2 times 20 is 10. So this is just 10x. So now what you're going to do is take this guy plus this guy plus this guy and set it equal to this 336 that we get in the problem, because the total value of all these bills is $336. So that comes from the total value of the 1s plus the total value of the 10s plus the total value of the 20s. So let's slide down here and set up our equation. So this will be x plus 2x minus 2 plus 10x. This equals 336. Okay, so x plus 2x would be 3x, and then plus 10x would be 13x. So this is 13x. Let's go minus 2 equals 336. Let's add 2 to both sides of the equation. And of course, this is going to cancel. So I'm going to have 13x is equal to, this would be 338 if I did 336 plus 2. Let me make this 8 better. And then I'm going to divide both sides of the equation by 13. So this would cancel. And you're going to get x is equal to 338 divided by 13 is going to be 26. So let's put this as 26 here. So I'm going to put this as 26 here. So that's the number of $1 bills. The total value would be $26. And I'll just put the dollar symbol there. For this one, if I plug in a 26, 26 minus 1 is 25. And a fifth of 25 is 5. So this would be 5 in terms of the number of $10 bills. So this right here would be $50 in total value. And then a half times 26 is 13. So this would be 13, and 13 times 20 would be 260. So this would be $260. So the first thing in order to check things is to go through and sum this. So 260 plus 50 is going to give me 310, and then 310 plus 26 is going to give me 336. So the total value matches up, the $336 that I was looking for. So again, this was 26, this was 13, and then this was 5. Now, just reading back through the problem, we've already checked this part right here. The sum is $336. We know that from the table. But you just want to go back through and check the other stuff. It says Melissa has double the number of $1 bills as $20 bills. Well, yeah, she has 26 $1 bills, and that is double 13, the number of $20 bills. Additionally, it says if the number of $1 bills was decreased by 1, so that means you would have 25, there would be 5 times as many $1 bills as $10 bills. Yes, 5, the number of $10 bills, times 5 is 25. Again, that's found by decreasing this number of $1 bills by 1. So this is our correct solution. Everything checks out. We would have 26 $1 bills, we would have 13 $20 bills, and we would have 5 $10 bills. All right, let's take a look at problem number 2. A very similar setup. So Thomas, a local street food vendor, has $467 in his bag. The bag contains $1 bills, $5 bills, and $10 bills only. The number of $1 bills is 1/3 of the number of $10 bills. Additionally, the number of $5 bills is 7 more than the number of $1 bills. How much of each type of bill, the $1 bill, the $5 bill, and $10 bill, is present in his bag? And let's let X be equal to, again, we have that the $1 bill is involved in each comparison. So I'm going to use that. Again, you don't have to, but it's just easier for me. So this should be the number of $1 bills. So let me make that more clear. So the number of $1 bills. Okay, so then how are we going to represent the other ones? So it says the number of $1 bills is 1/3 of the number of $10 bills. So that would mean that the number of $10 bills is 3 times the number of $1 bills. So let's put then, we'll say 3x is equal to the number of, in this case, we're working with $10 bills. And then lastly, it says the number of $5 bills is 7 more than the number of $1 bills. Well, the number of $1 bills is x. So what I'd want here is x. Let me put then first. So x plus, again, it's 7 more than, so x plus 7. This would be the number of, in this case, $5 bills. Okay, so we have everything modeled. Let's again go to the table. So we're going to have these $1 bills, the $5 bills, and then we're going to have $10 bills. And then we had for the number, we had x, then we had x plus 7, and then we had 3x. Okay, so the value each, this is going to be 1, this will be 5, and this will be 10. And again, you're just going to multiply across. So we're going to say the total value, here it's x, here it's 5 times the quantity x plus 7. And again, you can just multiply that through if you want. That's going to be 5x plus 35. So this is 5x plus 35. And then here it would be 30x. So 30x, let me make this 3 better. And let me make this 5 a little bit better so everybody can see clearly. So again, when we think about our equation, we know that the total amount in this guy's bag is going to be $467. Well, that comes from the total value of 1s plus the total value of 5s plus the total value of 10s. So let's go ahead and say that we have x plus 5x plus 35 plus 30x, and that equals, again, this is going to be 467. Okay, so the first thing I'm going to do is just combine like terms on the left. X plus 5x is 6x, plus 30x would be 36x, and then I'd have plus 35 equals 467. Let's subtract 35 away from each side of the equation, and so this right here is going to cancel. I'll have 36x is equal to 467 minus 35 is going to be 432. Then if I divide both sides of the equation by 36, this is going to cancel. And what we'll have is x is equal to, if I do 432 divided by 36, I'm going to get 12. All right, so coming back up here, I'm just going to replace everything because we know what x is now. So this is 12. This right here would be 19. And then this would be 36. Now multiplying across, this would be $12. That's the total value. Then multiplying across, again, you could plug in a 12 here, or you could just say 19 times 5, that's going to give you 95. So this is 95. And then over here, again, I could plug in a 12 here, or I could just say 36 times 10, that's going to give me 360. So 360. And again, I need the dollar signs in each case because these are going to be dollars in terms of the units. So if I did $360 plus $95, I would get $455. And if I added $12 to that, I would get $467, which is exactly what we're told is in his bag in the problem. Okay, so that part checks out. All right, so let's also fill this in. We'll say for the $1 bills, there's going to be 12. Remember, X was representing that. And then for the $10 bills, it's 12 times 3 or 36. And then lastly, for the $5 bills, it's 12 plus 7 or 19. So now just reading back through the problem to check the other parts, we have the number of $1 bills is 1/3 of the number of $10 bills. So you have 12 $1 bills, and that is 1/3 of 36, the number of $10 bills. So that checks out. Additionally, you have that the number of $5 bills, which is going to be 19, is 7 more than the number of $1 bills, which is going to be 12. 19 is 7 more than 12, so that part checks out as well. So this is our correct solution. We have 12 $1 bills, 36 $10 bills, and 19 $5 bills. All right, let's look at problem 3 now. So we have Helen visited the laundromat, which only accepts coins. She spent a total of $8.40 using quarters, nickels, and dimes only. She spent twice the number of dimes as quarters and 3/2 the number of nickels as dimes. How much of each type of coin did Helen use at the laundromat? So again, when I think about this guy, I'm given a total, it's $8.40, and I know I'm only using quarters, nickels, and dimes. So again, the same setup, but now we're using coins versus paper bills. So thinking about what I'm going to let X be equal to, you see that you have dimes and quarters and nickels and dimes. So I would let X be equal to the number. So let X be equal to the number of dimes because it's involved in both comparisons. Again, you don't have to do that, but it's just easier for me. And then if I think about it, it says she spent twice the number of dimes as quarters. So that means I have half the number of quarters as I do dimes. So let's put, then we'll go 1/2 X is equal to the number of, in this case, quarters. So quarters, like that. The other part here, it says 3/2 the number of nickels as dimes. So since I have the number of dimes represented with X, I can just go 3/2 X. That's going to be the number of nickels. So let's put then, we'll say 3/2 X will be equal to the number of nickels. Okay, so the first part is done. Again, I'm going to use a table to organize the information. So we have dimes, we have quarters, and then we have nickels. Okay, so again, I'm going to stick with the number. And again, I modeled this one with X. I modeled this one with 1/2 X. Because we're going to be working with decimals, I'm just going to put 0.5X. You can keep it as a half if you want, but I think it's easier just to stick with one type. And then with nickels, we had 3/2 X. So I'm going to put that as 1.5X, just like this. Okay, so for the value each, again, we're thinking about coins here. So a dime is 10 cents. So that's 0.1 in terms of the value. A quarter is 0.25. So 0.25. And then a nickel is 0.05. So then the next thing you want again is the total value. So let's put the total value. And so this would be 0.1X. Again, I'm just multiplying across. 0.5 times 0.25 is going to be 0.125. And then times X. And then 1.5 times 0.05 is going to be 0.075 and then times X. All right, coming back up here, remember, the total she spent was $8.40. So again, that's coming from here, plus here, plus here. So the amount she spent with dimes, plus quarters, plus nickels. So that has to be equal to $8.40. Let me slide down here. I'll say 0.1X plus 0.125X plus 0.075X is equal to 8.4. So again, you can work with the decimals or you can clear them. You need to multiply everything by 1,000 if you want to do that. So this is going to go 3 places to the right. So this would be 100X. Then plus, this would be 125X. Then plus, this would be 75X. And this would be equal to 8,400. So on the left, if we combine like terms, 100 plus 125 is going to be 225. Then plus 75 is going to be 300. So this would be 300x is equal to 8,400. Let's divide both sides of the equation by 300. So this will cancel. 8,400 divided by 300 is going to be 28. So we're going to have x is equal to 28. So coming back, this is 28. And then 0.5 times 28, or half times 28, is 14. So this is 14. And then 1.5 times 28 is going to be 42. So this would be 42. So again, you could just multiply across, or you can plug a 28 in everywhere you see an x. Same answer either way. So 28 times 0.1 would be 2.8, so $2.80. And then here, 14 times 0.25 would be 3.5, so $3.50. So $3.50. And then here, 42 times 0.05 is going to give you 2.1. So this would be $2.10. So if you add these guys together, $2.80 plus $3.50 would be $6.30. And then if you add to that $2.10, you're going to get your $8.40. So this part checks out. And let me actually write the answer in here. So this was 28. And then this was 14 because it was half. And then this was 42 because it was 1.5. Okay, reading back through again, you just want to check the other stuff. She spent twice the number of dimes as quarters. So here's quarters, it's 14. Twice that number is 28, so that checks out. And then the other part, 3/2 the number of nickels as dimes. So when I look at the dimes as 28, 3/2 that number would be 42, so that part checks out as well. So this would be our correct solution. The number of dimes would be 28, the number of quarters would be 14, and the number of nickels would be 42. All right, let's take a look at problem number 4. So we have that Garfield High School sold $7,500 worth of tickets to their basketball game. They received all payments in cash and with $20 bills, $5 bills, and $1 bills only. The number of $20 bills received was 3 times the number of $5 bills received. Additionally, if the number of $20 bills received had been 50 less, the number of $20 bills would be 1/4 the number of $1 bills. How many of each type of bill, $20 bill, $5 bill, and $1 bill, did they receive? Okay, so again, thinking about this, you see that the $20 bill is involved in each comparison. So I'm just going to start by saying that we're going to let x be equal to the number of $20, let me make this dollar symbol better. So $20 bills. So then how can I model the $5 bills and the $1 bills? Well, it says specifically that the number of $20 bills received was 3 times the number of $5 bills received. So that means the number of $5 bills received was 1/3 of the number of $20 bills received. So I'll say then 1/3 x is equal to the number of, in this case, it would be $5 bills. All right, we have one left. Let me make this S a little bit better. We have one left. That's the number of $1 bills. This one is a little bit tricky, but basically you want to start with this part right here. When you say if the number of $20 bills received had been 50 less. So just start by doing that. So what if it had been 50 less? Well, here x is the number of $20 bills. If it was 50 less, that would be x minus 50. So I'm going to say then, I'm going to leave a space, and I'm just going to put x minus 50. Okay, so if it had been 50 less, which we have here modeled, the number of $20 bills would be 1/4, okay? 1/4 the number of $1 bills. So this is 1/4 the number of $1 bills. So that means the number of $1 bills would be 4 times that. So I'm going to put 4 times this quantity. This is going to be equal to the number of $1 bills. Okay, so that's all it is. All right, so similar setup. Again, the total value here, or the total amount that they're taking in is $7,500. So I'm just going to set up a little table just so everything is organized and nobody gets lost. So we're going to go down here and let's put in the $1 bill, the $5 bill, and the $20 bill. Let's put the number. And in this case, we put this as x. We put this as 1/3 x. And we put this as 4 times the quantity x minus 50. Then you have your value each. So the value for each one, and again, that's real simple. You just take the value from over here. So this is 1, 5, and then 20. And then this right here would be the total value. So the total value. And we get this from multiplying across. So 1 times anything is itself. So I'm just going to distribute here and say this is 4x minus 200. And then here 1/3 x times 5. Let's say that's 5/3 x. And then here 20 times x would be 20x. So again, the idea here is that you're taking the total value from the 1s, which is 4x minus 200, plus the total value from the 5s, which is 5/3 x, plus the total value from the 20s, which is 20x. And you're going to set that equal to this $7,500. Again, that's what they took in. So let's take our 4x minus 200, then plus 5/3 x, then plus 20x. And again, this equals 7,500. If you want to clear the fraction, you can. You can also clean up a little bit before you do it. It might make it a little bit easier. So I would just combine everything that's not a fraction first, get as far as you can, and then clear the denominator. So 4x plus 20x would give me 24x. So this is 24x. And then I could also add 200 to both sides of the equation while I'm doing that. So this is going to cancel. Let me put plus 5/3 x like this. And then what this would be equal to is 7,500 plus 200, which is 7,700. Okay, so from here, now I can clear the denominator. So I can multiply everything by 3. 24 times 3 is going to be 72. So this would be 72x. And then plus 5x. Here, 7,700 times 3 is going to be 23,100. So again, if I combine like terms over here, 72x plus 5x would be 77x. So this equals 23,100. Let's divide both sides of the equation by 77. And so this cancels. You're going to get x is equal to 23,100 divided by 77 is going to give me 300. So x is 300. And again, that's the number of 20s. So this is 300. A third times 300 would be 100. And then 300 minus 50 is 250. And then times 4 is 1,000. Let's put 1,000 there. And then coming through here, again, you can multiply across or you can plug in a 300 everywhere there's an x. It's really up to you. I'm just going to multiply across. I think that's easier. So 1,000 times 1 is just 1,000. So this would be $1,000. And then this would be 5 times 100. That's $500. And this is 20 times 300. 2 times 3 is 6. And you'd want 3 zeros. So this is 6,000. So $6,000. Again, if you sum these amounts, you're going to get 7,500. $1,000 plus $500 is $1,500. And then plus $6,000 will give you $7,500. So that part checks out from here. So again, for the $20 bills, there's going to be 300. For the $5 bills, there's 100. Let me make this 0 a little bit better. Kind of looks like a 6. And then for the $1 bills, this is supposed to be 1,000. Okay, checking this again, we know that the 7,500 part is good to go. But going back through, it says the number of $20 bills received was 3 times the number of $5 bills received. We have 300 for the number of $20 bills, 100 for the number of $5 bills, so that checks out. Then it says additionally, if the number of $20 bills received had been 50 less, so it would have been 250, the number of $20 bills would be 1/4 the number of $1 bills. Yes, 250 is 1/4 of 1,000, so everything checks out here. This is our correct solution. We're going to have 300 $20 bills, 100 $5 bills, and 1,000 $1 bills. All right, let's take a look at problem number 5. So we have that Maggie has a piggy bank with $53.14. Her piggy bank has pennies, nickels, dimes, and quarters only. The piggy bank has 9 fewer nickels than pennies and double the number of dimes as nickels. Lastly, if the number of quarters was reduced by 1, there would be 6 times as many quarters as nickels. How much of each type of coin is in the piggy bank? All right, so once again, I'm going to think about nickels because that's involved in all the comparisons here. So I'm going to let x be equal to the number of nickels. And then just reading through, it says that the piggy bank has 9 fewer nickels than pennies. So that means pennies would be 9 more. So let's say then, I'm going to put this over here. I'm going to put then. We'll say x plus 9. So the number of nickels plus 9 more would be equal to the number. Let me make this better. So the number of, in this case, it would be pennies. Then we have double the number of dimes as nickels. So take the number of nickels, which is x, and double that. That's 2x. That's going to be your dimes. So let's put then. We'll say 2x is equal to the number of, in this case, dimes. And then lastly, we say that if the number of quarters was reduced by 1, there would be 6 times as many quarters as nickels. Okay, so this one's a little bit tricky. What you would want to do here is first start out by saying 6 times as many quarters as nickels. So I could take the nickels, which is x, and I could multiply it by 6, and I would have 6x. So let me start with that. So I'm going to say then, I'm going to say 6x. But this does not represent the amount of quarters we have. It specifically says if the number of quarters was reduced by 1, I would have this. So this represents the number of quarters reduced by 1. So to get it back to where it needs to be, I need to add 1 to undo that. So it would be 6x plus 1. So this would be equal to the number of, in this case, quarters. Let me make this A a little bit more legible. Let's go to the table, and I'll put pennies. I'm just going to abbreviate stuff. So pennies, I'm going to put nickels, and then quarters, and then dimes. So this is the number. And again, we just modeled that. So the nickels, that was x. The pennies was x plus 9. The dimes was 2x. And the quarters was 6x plus 1. So 6x plus 1. And then you have the value each. So for a penny, it's 0.01. For a nickel, it's 0.05. For a quarter, it's 0.25. And then for a dime, it's 0.1. So again, for the total value, you're just going to multiply across. So this is going to be 0.01 times the quantity x plus 9. This will be 0.05x. This will be 0.25 times the quantity 6x plus 1. And this will be 0.1 times 2x. Let's just go ahead and say this is going to be 0.2x. And these I think we should probably just do before we set up an equation. So this is going to be 0.01x and then plus 0.09. So let's just replace this with this. I'm just going to slide this in here. Might not fit, but I think that's good enough. We can see it. Then for this one, 0.25 times 6 is 1.5. So this would be 1.5x and then plus 0.25 times 1 is just 0.25. So again, let's just slide this in. It's not going to fit, but that's okay. Let's just slide this in like this. So going back up, again, the total value of the piggy bank is $53.14. So to set up an equation, I'm going to take the total value of the pennies plus the total value of the nickels plus the total value of the quarters plus the total value of the dimes and set that equal to 53.14. So let's go 0.01x plus 0.09 plus 0.05x plus 1.5x plus 0.25 and then plus 0.2x. And this equals, again, 53.14. All right, so you can always clear decimals if you want. Just multiply everything by 100. So this right here would go 2 places to the right. So this would be x and then plus. This would go 2 places to the right, so that's 9 and then plus. This would go 2 places to the right, so 5x and then plus. This would go 2 places to the right, so this is 150x. And then plus 2 places to the right, this would be 25. And then plus, and then 2 places to the right, this would be 20x. And this equals 2 places to the right here, this would be 5,314. I think it's pretty straightforward from here, just a lot of cleaning up. So x plus 5x is 6x, plus 150x would be 156x, then plus 20x would be 176x. So this is 176x. And then 9 plus 25 is going to give me 34. So plus 34. Let me make this 3 better. And this equals 5,314. So what I'll do from here is subtract 34 away from each side of the equation. This would cancel. You get 176x is equal to 5,314 minus 34. That's going to be 5,280. Let's divide both sides of the equation by 176. And so this is going to cancel. You get x is equal to 5,280 divided by 176 is going to be 30. So x is 30. Again, that's the number of nickels. So coming back up here, I just cleared this column because we're just going to multiply. So this is going to be 30. And 30 times 0.05 is going to be 1.5 or $1.50. Let's just put it like that. And then if I plug in a 30 here, this would be 39. So this would be 39. And we know if we had 39 pennies, that's just 39 cents. So let's put $0.39 like this. And then for this one, if I plug in a 30, 6 times 30 is going to be 180. Then plus 1 is 181. So this is 181. So if I multiply 181 times 0.25, I'm going to get 45.25. So $45.25. And then lastly, 2 times 30 is 60. And then 60 times 0.1 is going to be 6, or in this case, $6. So if we sum these amounts, 39 cents plus $1.50 would be $1.89. And then if I add $45.25, I get $47.14. Then if I add $6, I get my $53.14 that I was looking for. So we know this part checks out. We just need to check the rest. So again, this is going to be 30. And then pennies, this was 39. Dimes, this was 60. And quarters, this was 181. Again, we've already checked this part right here. We know the sum is correct. Let's just go back through the other parts. So it says 9 fewer nickels than pennies. Yeah, I have 30 nickels and 39 pennies. That's good. Double the number of dimes as nickels. Well, I have 60 dimes and 30 nickels, so that's good. And then it says if the number of quarters was reduced by 1. So if I had 180, it would be 6 times as many quarters as nickels, right? Because 180 is 6 times 30, so we're good to go there. So everything checks out. This is our correct solution. There's going to be 30 nickels, 60 dimes, 39 pennies, and 181 quarters.